Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So in this video, we still discuss about the topic permutation and combination, where we still discuss about permutation. So we continue our discussion regarding conditional permutations. So in example 16, 4-digit numbers are to be formed from the digit 0, 1, 2, 3, 4, 5, and 6. So you count it from 0, it should be total 7, okay? Total 7 digits. Without repetition, how many numbers can be formed if the number is less than 5,000? Okay, so the rest of the question would be on the next slide. So look at the first one, it's less than 5,000. So firstly, it's less than 5,000 means that the first digit at the front should be 1 until 4. So we can choose, there are 4 choices here, so we put it 4 in the first place, either 1, 2, 3, and 4. And then for the second place, okay, total 7 digit, we already used 1, so we still have 6 digits, okay, including 0. And then after we using for the second digit, we still have 5 for the third place. And lastly, for the fourth place, to complete the 4 digit, we still have another 4 remaining digits to choose. So the cancel out here suggests the example of digit they already used for the second, third, and fourth place. Okay. So using this method, you can, to find the total number of arrangement, so we can just multiply 4 times 6 times 5 times 4. So we got the total arrangement is 480. But this method is quite consuming and maybe certain students find it a bit confused. So alternatively, I suggest you to use this method. So I will focus only on the first place, right? Because since we want number less than 5,000, so only first place is very particular here, because you only can choose from number 1 to number 4. So we have 4 choices for the first place. So the remaining 3 places here we can occupy from any remaining 6 digits, including 0. Okay. So alternatively, here is very more straightforward. So we just multiply, okay, including 0. Don't forget, including 0. So the number of arrangement we just multiply 4 here for the first place, and the remaining 6 digit we choose another 3. So we can find out the number of arrangement is 480. So later on in the next example, I will use this kind of solution because it is more understanding and it's not too complicated compared to the previous method. Okay. Right. So next we move to the question B. So next, begin with digit 4 and 6. Remember, we still have the same question from digit 0 until 6. Okay, remember, as I said in the previous, we have total 7 digits. Right. So move to the question B. So in order to begin 4 or 6, so we have 2 choices. Okay, either 4 or 6. So 2 choices. So this is the particular one. So the remaining, just like the previous question, so we already used from the 7 digits. So we remaining, or we still have 6 including 0. So we choose another 3 digits. So 6p3. So the arrangement just multiply 2 times 6p3, and then we got the total number of arrangement would be 240. Right, next for C, between 2,000 and 6,000. So remember, in order to become 2,000 and 6,000, so I just write down here. So let's say we have 2,000 and here we have 6,000. So in between, it can be 2001, but lastly, it cannot exceed 6,000. So it must be 5,000 and something. In other words, so for question C, the first place should be occupied by digit 2, 3, 4, and 5 because it starts with between 2 until before 6. So just before 6 would be 5. Okay. So this number that will occupy the first place. So 4 digits. From 4 digits we choose 1. And then same as the previous question. So we can choose the remaining 6 digit to choose another 3, include 0. So the number of arrangement will be 4 times 6p3 and the total arrangement will be 480. Right, lastly for D, it is an odd number. So you know what is odd number? So the odd number means the last digit must be either 1, 3 or 5 in order to be odd. So from this 3 means that we have 3 choices for the last place. So what's what the remaining places here? Okay, we cannot do like the previous question because the number at the back can include 0. However, the number at the front cannot include 0. So you have to choose the first place first. So means that we have to be 5. It cannot be 6 because we have to exclude 0. So it should be 5 only. So from 5 we choose 1. And then the remaining we can include 0. So that's why the number starting here is also same as 5 because this one is we exclude 0. And then here when we include back 0, the total digit here still 5. So 5p2. Okay. So in other words, the number of arrangement will be 5p1. Okay. It exclude 0 and exclude the last place. And then 5p2, the remaining 5 digit, we choose another 2. And then 3 for the last place in order to become odd. So the total number of arrangement will be 300. Okay, same as the answer. Right, so next we move to the example 17. How many 4 digits even number can be formed? So the word highlighted here, even number. So you should know what is even number means, right? So even number means the last place here either 2 or 4. Okay. So let's say if we already choose 2 on the last place, so the remaining at the front here cannot include 2. Okay. So here are 2 choices, either 2 or 4, but here only 3. It cannot be 4 because let's say we already use 2 from the last place. Remember, we start with the last to make it even number. So at the front, since it is also between 2000 and 6000, so from 2, 3, 4, 5, we only choose 3 because one of them, either 2 or 4, already used at the back. So let's say we choose 2. Okay. And then the remaining, we still have 5 digits. So no, this time it's 6 because from 0 until 7, total we have 8 digits this time. Okay, total we have 8 digits. So we choose already on the first and the last and the first, so we have still remaining 6 digits. So this 6 digit also include 0. Okay, so the number of arrangement would be before that, actually in this case we have to consider 2 cases because since it is mentioned about even number, we know even number 2, 4 or 6, right? But here at the front, it can be compromised between 2 and 4. So that's why one of the possibility here, we choose either 2 or 4 at the back. So the remaining at the front here we reduce by 1. Okay, understand? So another possibility is we choose 6. So if you choose 6, at the front we can choose 2. So here at the front it will be 4 choices. And then in between, this one is same, okay? It is 6p2. So here we have two possibilities. So two possibilities, we have to add between these two possibilities. So our arrangement would be 3 times 6p2 times 2. So this is the first possibility, plus, okay? All means plus. Another possibility, 4 times 6p2 times 1. Okay? So the total number of arrangement should be 300. So the answer given is incorrect, okay? So B already out of question lah. So that's why I cancel out question B. So we focus only on question A, but the answer is incorrect. So we use this answer 300. I already checked, and we using another method, we still got the same answer 300. So this should be the correct answer for this question. Okay. So this, remember this question, maybe many of you will find it very confusing because we have two possibilities here that we have to sum all these two possibilities. So remember, next time if you come across with this kind of question, you have to consider the two possibilities of cases here. Right. So next we move to the example 18. 3 married couple have bought 6 seats in the same row for a concert. In how many different ways can they be seated? A, with no restriction. So in this question we only focus on question A, no restriction. So no restriction means the 3 seats free seating, okay? So 6 factorial would be 720, okay? And then next, B, if each couple is to sit together. So couple sit together means like this. So we have 3 places, okay? We group together husband and wife into one group. So total we have 3 groups. And inside here, between husband and wife, they also can switch places. Maybe husband on the left or husband on the right. So same also for another 2 couples. So it means that the arrangement for question B would be, so the arrangement between husband and wife inside the couple. And then lastly, 3 factorial means between the couple itself. Okay, how we arrange. So maybe the first couple want to be at the left, maybe in the middle. So that's why we have 3 factorial we have to consider. So we multiply all this, and then we got the total arrangement will be 48. Right? Right, and then next C, if all the men sit together to the right. Okay, they already mentioned the location on the right. So it means that the husband means that the man, okay? Husband would be the man on the right. So it cannot switch places between husband on the left or right. They already fixed on the right like this. So means that our arrangement will be inside between the husbands and inside here between the wives. So means that 3 factorial and 3 factorial only. So this is the only arrangement that we have to consider. So the total arrangement will be 36 for question C. Right, next, I read here because maybe you cannot quite clear here. So permutation where some objects are repeated. Okay, we consider repeated cases here. So let's say the word banana here. So inside the banana we have 3 times of A and 2 times of N. So the total arrangement from 6 factorial we have to divide with the same letter. So we have to divide with 3 factorial for A and 2 factorial for N. So the number of arrangement will be 6 factorial divided by 3 factorial and 2 factorial. Okay. So let's see the example in the next question. So in example 19 here, how many different permutation can be made using the letter for the word? So let's see the first one, books. So books we have total 5 letter, and inside here we have 2 O's. So we have to divide by 2 O's here. So 5 factorial divided by 2 factorial. So we got the number of permutation would be 60. And then next, lotto. So from lotto here, 5 letters here, and we have 2 O's and 2 T's. So 5 factorial divided by 2 factorial and 2 factorial. Then we got the number of arrangement will be 30. And then lastly, mathematics. So mathematics here, with total we have 11 letters, so 11 factorial. But inside here we have 2 M's, 2 A's, and 2 T's. So we have to divide by these 2 M, 2 A, and 2 T's. So the number of arrangement will be 4,989,600. Okay. So next, for example 20, there are 2 copies of each 3 different books. So we know the total number of books would be 2 times 3, 6. And since we have 2 copies for each 3 books, so we divide by 2 factorial, 2 factorial, and 2 factorial. So the number of arrangement would be 90. And then in example 21, so in the word adding here, so let's see what happens if the 2 D's are together or separated. So let's say the first one, if the 2 D's are together. So if together, we consider the 2 D's as a one place. And the remaining, we have another 4 letters. So total here, 1 plus 4. So we have 5 factorial. Okay. So 5 factorial. So since we already consider these 2 D's as 1, so no need to divide. Okay. Unless you want to put 2 factorial divided by 2 factorial. So the answer will be same as 1. So that's why I already phase out 1 only. So no need 2 factorial divided by 2 factorial. Okay, only 1. Okay, already say away 1. Right. So next for second question, separated. Remember the previous example they already discussed in the previous lecture. So for these cases, we have to list out the remaining letters. So the remaining letters, apart from the D's, we have 4 letters. So 4 letters here, between here we can rearrange. So we have 4 factorial here. And in between the 4 letters, we have 3, and at both ends we have 2. So total we have 5 places that we can slot in the 2 D's. However, the 2 D's are the similar letter, so we have to divide by 2 factorial. Okay, so the solution will be 4 factorial for the other letters. So for here, for adding to insert the letter D and divide because we have similar D's. Okay, so the number of arrangement here will be 240. Right. So next we move to the example 22. So the question here, how many different arrangement are for the word arrangement? So the word arrangement total we have 12 letters. Okay. So between the 2 letters we have 2 A's, 2 R's, 2 N's, and 2 E's. So for the first question, it begins with R and ends with E. So start with R and end with E. So we notice that R we have 2, E also we have 2. So since already used up R and E, so we already remaining only 1. So for the remaining 6 letters, we only need to divide by 2 A's and 2 N. So no need more R and E because R and E already used at the first and the last place. Okay. So the number of arrangement will be, we will multiply together 1 times 10 factorial over 2 factorial for A and N. And then we got the total number of arrangement will be 907,200. Okay. Alright, next for question B, the 2 letters E are separated. Remember, the case separated they already discussed earlier. So we list out the remaining the remaining. So the remaining we have 10 letters. So 10 letters apart from E we have another 10 letters. So 10 letters here, apart from E we still have 2 A's, 2 R and 2 N's. So we have to divide these 10 factorial with 2 factorial for A, 2 factorial for R and 2 factorial for N. And then here we have to want to slot in the E's. So in between we have 10 places, and at both ends we have another 2. So total we have 11 places that we can slot in the 2 E's. So 11 P2. And again, since the 2 E's are similar, so we have to divide by 2. So the arrangement would be 10 factorial over 2 factorial, 2 factorial for the other letters, and then here for the slot in of letter E. So the number of arrangement, we just press your calculator, and then your calculator will give the answer is 24,948,000. Okay, quite big number. Right, next for question C. So for question C, the 2 letters E and 2 letters A are together. So let's see what happened we have put together. So means that the 2 E's we consider one place, 2 A's also consider one place, and the remaining, so remember total we have 12, right? So subtract 2 E's and 2 A's, we have another 8 letters. Okay, so already list out the other letters here, so it should be 8 here. So from these 8 letters, we still have 2 similars R and N's. So it means that the total arrangement 1 plus 1 plus 8, so it will be 10. It should be 10, and then divide by, we still have 2 R's and 2 N's. And then don't forget this one, or as I mentioned earlier, we don't consider divide by 2 factorial, okay, for E's and A's, because we only consider 1. So do not to divide lah, because it is already 1. Okay. So total will be 10 factorials over 2 factorials, 2 factorials. So remember these 2 factorials again for R and E. So the number of arrangement here would be 907,200. Okay. Right, next for question D, the consonant G, M, T, S are together. So G, M, T, S are together, we consider one place. And the remaining, we have another 8 letters, okay? Because total is 8. Total is 12. So minus 4, so we should have another 8. But don't forget, inside here, GMTS is 4 different letters. Okay, it's not same like this one. So we still have 4 factorial inside here. And then so we already I also list out the same letters here. So we have 2 R's, 2 A's, 2 N's, and 2 E's. So the number of arrangement 1 plus 8. So 1 together and the others 8. So 1 plus 8. And then divide this one. So we have 2, 2, 2, 2. So we have 4 here. We have to divide 2 factorial 4 times. And then 4 factorial here for inside the consonants. Okay. So in short, we can summarize 1 plus 8 will be 9 factorial. And then 4 factorial we bring together above here. So below here 2 factorial, 2 factorial, 2 factorial, 2 factorial. Then we can press calculator easily. Then we got the answer is 544,320 for question D. Okay, and then lastly for question E, the 2 letters N occupied both ends. So we list out here N on the first and the last place. So we only 1, 1, so we don't consider the arrangement for N anymore. So we only consider the in between. So in between total we have 10. After we subtract these 2 N, so we have another 10 letters. And apart from N, we still have 2 A's, 2 R's, and 2 E's. So the first and last place, so we consider one arrangement. So in between we have 10 letters, so 10 factorial, and then divide by 2 A's, 2 R's, and 2 E's. So press your calculator and you got the answer 453,600. Okay. for the last question. Okay, so I think that's all for the example regarding the permutation. I hope you can answer the question in the tutorial, so make sure that you understand how to find the arrangement. Okay, don't forget, in the next lesson we will discuss about combination. So thank you very much. Until then, bye bye.